For most of the rest of this course, we're going to be looking at the diversity of organisms that we share this planet with. And there are a few overarching principles that I'd like to acquaint you with today, because we're going to be seeing them again and again as we look at examples of real organisms doing what real organisms do. One of these overarching principles is that form follows function. And this is a natural outgrowth of what you've been learning about ecology and evolution. Ecology, the interactions that an organism participates in, challenge it in certain ways that an organism needs to be able to survive and reproduce in the face of. So, for example, an organism needs to find enough of a particular kind of food. It may be that food is scarce. It may be for carnivores that food runs away. But whatever the kind of food that an organism needs, it has to be equipped to find it, get a hold of enough of it, and digest it, enough to keep itself alive and have offspring. The form of an organism, as well as its behavior, is generally tailored to the particular environmental challenges that it faces in a particular context. So, for example, if you take a look at the beaks of birds, you'll see that their form, their shape, follows their function, the way that they work in a particular ecological context. Here, for example, is a cardinal, and it has a beak that is very effective at cracking seeds and extracting the useful meat inside those seeds. A hummingbird's beak is very long and thin. It's ideal for reaching into deep tubular flowers for nectar. The beak of a hawk is excellent for tearing apart flesh, which is what it feeds on. Woodpeckers have a very long straight beak for pounding into the wood of trees to find insects that are living within them. Here's a bird with a long curved beak that's very good at probing into the mud after things like bivalves or snails. And of course, this beak, I'm not sure what this beak does, but it's probably something functional. You should also remember from way back when we were studying evolution that there are a couple of themes that we looked at, and we'll be seeing them coming up again for the rest of the course. One of the things that we know to be true from our study of evolution is that all living organisms share a common ancestry. And of course, some organisms share a lot more common ancestry with one another than they do with, say, some third organisms. So, for example, birds and reptiles share a lot of common ancestry that they don't share with, say, clams. And this is the explanation for why birds and reptiles are so similar in many different ways. However, we've just been talking about how form follows function, and same thing with behavior. The form and behavior in an organism are shaped by natural selection. While there are other forces that act on that form and that behavior, natural selection is very important. So when we look at the way that organisms are shaped, the way that they behave, we need to be thinking about two things. We need to be thinking about how they're shaped by the challenges of their environment, what natural selection is doing. But we also need to think of what they've inherited from their history, because that history sets very rigid boundaries on what natural selection can do in the present day. So you see these two things, adaptation of the environment and evolutionary history, intertwining to make organisms what they are now. As an example, on the two extremes of this slide, we've got two organisms that are very, very different. Here's a seal over on the left, and here's an ostrich over on the right. In the middle, there's a penguin. Now, the penguin looks, in terms of its shape, very much like the seal. And the reason is that they share similar ways of making a living. They both swim underwater, and so they both have this very streamlined shape. They have these flippers that propel them along swiftly so that they can catch their food, which is fish in both cases. So natural selection accounts for these similarities here. But The similarities and differences among organisms can be a result of what they've inherited. So for example, the fact that the penguin has feathers and a beak is explained by its ancestry with birds. Ostriches also have feathers and beaks, even though they live in a very different environment, even though they do very different things with those feathers and that beak than penguins do. We're going to be looking a lot at adaptation and adaptations over the rest of this course. An adaptation, used as a noun, is a trait that helps an organism to survive and reproduce in some particular environment. And one thing I want to caution you about, because this is something that professional biologists have sometimes fallen afoul of, is that not every trait that you see on an organism is necessarily an adaptation. There are some traits that are likelier to be adaptations than others. So for example, if you see that a lot of different organisms that have a similar lifestyle also have certain traits in common, that suggests that that trait is important for living that lifestyle. However, there are some cases in which this principle does not hold true. So for example, if you look at woodpeckers, you'll see that they come in a remarkably limited set of colors. Basically, all woodpeckers are some variation on red and white and black. Now, it might be that red and white and black are important for an organism that makes its living drilling into the wood of trees after organisms that live inside that wood. However, there's another explanation, another possible explanation that is perhaps a little more, makes a little bit more sense. Suppose that you had at one time some primordial woodpecker, the first woodpecker ever to evolve, and it was red and white and black, and it made a living hammering out chunks of wood and trees and eating things that lived inside. And then it went through a radiation of speciation, resulting in all these different birds that inherited the tendency to hammer away into wood, but also the tendency to be black and white and red. Okay, so a trait that's shared among many similar organisms may be related to the similarities in their lifestyle, but it also could be that the lifestyle and the trait are traveling together just because they were inherited from the same common ancestor. In which case, the fact that red and white and black are found together with the woodpecker lifestyle might be nothing more than a coincidence. If this primordial woodpecker had been like yellow and purple, what we might see today are a bunch of yellow and purple woodpeckers. The case that a trait is adaptive is much stronger if you can identify the function of that trait, but it's also another thing you can look for is, has this trait evolved multiple times in species with this particular lifestyle? Okay, if it has, what you've got are what are called phylogenetically independent events. So where something has evolved just once, and it happens to be found in all woodpeckers, maybe that's just happened to be that way. If something has evolved twice and it's associated with the same lifestyle, well, it could be a coincidence. But if something has evolved many times in conjunction with the same lifestyle, then it probably is a functional trait, an adaptation to that way of making a living. And a great example of this would be sort of that streamlined body shape that we saw in seals and penguins and lots of other organisms that live aquatic lifestyles. Many times terrestrial organisms have evolved to become aquatic, and they pretty much always take on that streamlined shape when they do so.